So today we're starting module 9, and if you look on the calendar, the first lesson of module 9, so 9.01, is actually going to take us all week. Right? There's a bunch of parts to it, so we're really breaking it down so that you are really understanding. But today and tomorrow should be a bit of review because we're going to be solving quadratics by factoring. So here's the success criteria. We'll go over the success criteria more during the lesson because there's like some step-by-step. Here's some videos. The first two are not created by me. This one down here is from last year. And then, of course, I always record all of the lectures so that if you're ever absent, you can find them in the daily slides. So that'll be uploaded later. You also picked up a worksheet, and if you want to write this on the worksheet, that'd probably be in your best interest. Since they all have kind of similar names, this way, if you write it in the corner, you know which link to upload it to. So just take a minute in the corner of your worksheet, write 9.01, solving quadratics by factoring, day 1. 9.01. Solving quadratics by factoring, day 1. So that when you finish it, you'll take a picture of it and upload it to this link in Schoology. And also you can write on that paper evens or odds. I do not need you to do all 20 problems, just evens or odds on that. Questions? You probably won't have time in class today to work on those, but you will have time tomorrow. So you'll do probably both the day 1 and day 2 practices tomorrow in class. All right, but to jump into the actual lesson, so this whole module is about what's called quadratics. So we've learned about like linear functions. So linear functions look something like that, right? And their equations are y equals mx plus b. And then we have stuff for exponential functions. So stuff that looks like this or that looks like that. And those equations were like y equals b to the x. All right, we've learned about these extensively like last semester. What we're learning about today and for like the next few weeks are going to be graphs that look like this, like U-shaped graphs or parabolas. So these have the equation ax squared plus bx plus c. All right, and we'll do more of an introduction to quadratics on Wednesday, but just to kind of show you, like here's the equation that produces graphs that are U-shaped. Doesn't this, like right here, look a little familiar from the last unit? Yeah. I'm hoping that it does. But we learned how to factor quadratics before. Now we're just going to practice it more like specific to quadratics. All right, you should know, well not you should know, but I'm teaching you today, that quadratics will have a degree that is 2, like for the entire equation. So the exponent will never be bigger than 2 for the entire equation. So it could be something like this, like 3x squared plus 2x plus 9. Or it could be something shorter, like x squared plus 4x, or x squared minus 81, or even just x squared. As long as the degree is no higher than 2 for the entire equation, then it'll produce like a U-shaped graph. All right, so these are all quadratic functions. Questions about that? All right, so then to solve quadratic functions by graphing, I want you to kind of imagine that this is on a coordinate plane. So like here's the x-axis and here's the y-axis. How many times does this line cross the x-axis? Twice, like right here and right here. So when we're solving quadratics by factoring, we're basically figuring out what the x values are at these locations, right? And that'll be useful in the future too, but just let you know that's what we're solving for. So then on your actual note sheet, you have some steps at the top. And we have an example that we'll do together with the steps. So first thing is to set the quadratic equation equal to 0. So here's my quadratic equation. The degree of the whole thing is 2. And right now it's equal to y. We're going to change that y to a 0. So we get 0 equals x squared plus 3x minus 10. Right, that's what the first step tells us to do. The next step says to factor one side. All right, so I want you to change that to factor one side, because it could be the left side or the right side. All right, factor one side. So we can factor this right side of this using what method? The diamond method. All right, I know it's been a whole week, so we're kind of refreshing your memory. What number goes at the top? Good. What number goes on the bottom? And then I need to come up with two numbers that multiply to -10 but add to 3. So what are some numbers that multiply to 10?
5.
Good. One of them has to be negative. And which one will it be in order to add and get a positive? Good. Because I could try it out on the 5, but then that would make this a -3. When I put the negative on the 2, it works for the entire diamond. Right? It multiplies to -10 and it adds to a +3. All right, questions about that? Bringing back memories. All right. So then, right now, what we have so far is 0 equal to x minus 2, because it was negative over here, times x plus 5, because it was positive over here. Now, step 3 is to set each factor equal to 0. So factors are things that are multiplied together. So that means these parentheses are being multiplied together. So we're going to set each one equal to 0. So I have x minus 2 equals 0, and x plus 5 equals 0. And we're going to solve for x. I know it's been a while since we solved equations, but you're basically doing the opposite of what's being done. So what's the opposite of subtracting 2?
Adding.
Good, so add 2 to both sides. Cancels out on the left. On the right, 0 plus 2 is 2. Over here, what's the opposite of adding 5? Good, so do that on both sides. And we get x equals -5. All right, the last thing would be just to write your answer using curly braces, which basically means write it in this format. So they're like fancy parentheses. So it's like 2, -5. All right. And then that's it. Questions about that? You guys think you could try number 1 like that? Or do you need to see another one?
I vote we try.
Okay. So try number 1. We'll still go over it too, but just try going through the step-by-steps. Set it equal to 0, factor one side, and then solve for each factor. I'll give you about a minute. First step is to set it equal to 0. So is this one equal to 0?
Yes.
Yes. So step 1's already done. Second step, factor one side. So I'll do that over here. Can I use the diamond method to factor?
Yes.
Yes, because the leading coefficient is 1. All right, so when it's set up like this, you can use this method. What numbers multiply to 3 but add to 4? Good. So far, if you got this far, good job. You should have x plus 3 times x plus 1 equal to 0. All right, any disagreements there? All right, so now step 3, set each factor equal to 0 and solve each factor for x. So we're going to set x plus 3 equal to 0 and x plus 1 equal to 0. What's your first x value? Good, because you should have subtracted 3 from each side, so that is your x value. And what's your second x value? Good. And then I know I found the right ones because when I put them back in, -1 plus 1 is 0, -3 plus 3 is 0. So then just write your answer with the curly braces. So -3, -1 is your answer. All right, makes sense? All right, so those ones are when you factor using the diamond method. We're going to look at other examples of or other ways that we factored. So you've already learned how to factor all of these methods we're going over today. Now it's just the added step of solving for the quadratic. So I'm going to have you look at something different, like number 9. That's on the back side. Because all the ones on the front side, you can use the diamond method. And I'm confident in you guys knowing how to do that. But if we look at number 9, I know it looks a little different. We're missing a term, but it's still a quadratic equation. And it is still factorable. Anyone know how we factor number 9? Yes, Landon? I can't use a diamond method.
You have to.
What do we usually check for first? Not like terms, but we always check for a what first? Anyone?
GCF.
Good. So always check for a GCF first. If you can't use the diamond method, maybe see if there's a GCF that you can factor out. All right, so I would write this up here to remind myself. These ones are all factored with GCF. Also, a little side note on the test, that seemed to be what people struggled on was the GCF one. All right, so we'll go over it right now. So is there a GCF in number 9? If so, what is it? So between 1 and 8, the GCF is 1, but we don't really care where the GCF is 1. Can I factor out any x's? Good. I can factor out just one x because there's an x in each term, and the most I can factor out is 1. So once you've identified your GCF, so from the handful of tests that I graded, everyone was really good at identifying the GCF. You are going to now divide the GCF from each term. And when you write your answer, you have the GCF on the outside. And in the parentheses is what you get from dividing. So what's x squared divided by x? Good. What's negative 8x divided by x? Good, because the x's cancel in that term. So this is what we have so far for factoring. Does that make sense? Anyone confused on how we got here? All right, now the next step is to set each factor equal to 0 and solve for x. Well, I know this looks different from the ones that we already did, but keep in mind factors are things that you multiply together. So I'm multiplying this x times this set of parentheses. So x is one of my factors. So I'm going to set that x equal to 0, because that's one of my factors. And then I also set the parentheses equal to 0. That's my other factor. And then solve for x. So on the left side, the x is already isolated, so that's going to be part of my answer, is the x equal to 0. On the right side, we need to isolate the x. So what's the opposite of subtracting x? Good. Do that on each side. It cancels out on the left side. And then 0 plus 8 is good. So then my final answer written with those curly braces is 0,8. Questions, comments? All right, I'm going to have you try number 10, which is just like the one we just did. All right, so check for a GCF. If there is one, divide it from both. All right, so for number 10, is there a GCF? And if so, what is it? 3. Good. So then our GCF is 3x. Sorry, my thing won't unfreeze. Okay. GCF is 3x, so divide it from each term. What is 3x squared divided by 3x? Good, just x. What is 15x divided by 3x? Good, because the x's cancel. 15 divided by 3 is a positive 5. Now set each factor equal to 0. So first I have 3x equal to 0. And then I have x plus 5 equal to 0. So reminder, isolating a variable means doing the opposite of what's being done. What's the opposite of multiplying by 3? Good. So do that on each side. Cancels out on the left side. What's 0 divided by 3? It is 0. You can check it in your calculator. So good, that's one of my answers. Now solve for x on the other one. So opposite of adding 5 is subtracting 5. What you do on one side, you have to do to the other. So then x equals, what's 0 minus 5? 0 minus 5?
Oh,
Negative 5.
you said divided. I was like, what?
No. All right, and then last part is just to write your answer with the curly braces. So our answers are 0 and negative 5. Sorry, there's a negative here. Questions, comments, conundrums? Is that making sense?
Yeah.
All right. So just another refresher down here. for 13 through 16. What do these look like? Anyone know what that's called? I have two terms. I think I heard someone whisper it. But I have two terms, and are there perfect squares on each side?
We're all subtracting.
Good, they are all subtraction. So that's where we get a difference of squares. All right, I know it's been a whole week. We probably forgot about these. But do I have perfect squares on each side of the minus sign? Yes. What's the square root of x squared? And what's the square root of 64? It is 8. And it's a difference of squares because there's a minus sign in the middle. So I'll write the rule right here just to kind of help you out. So if it looks like a difference of squares in that format, then to factor it, it's going to be a plus b times a minus b. So then to put this in the rule that we just went over, it's going to be x plus 8 times x minus 8 equal to 0. Questions? All right, now set each one equal to 0. So set each factor equal to 0. I have x plus 8 equals 0 and x minus 8 equals 0. What's the first value of x? What plus 8 equals 0? Good. The second value of x is a positive 8. Because then when you plug it back in, 8 minus 8 equals 0. Questions about that one? So negative 8 and 8 are our answers to that quadratic. For the sake of time, I'm going to show you another example to kind of complete this video. And then we'll start out tomorrow with the ones, like the U tries for the ones we didn't go over. All right, but before we do that, any questions? All right, so scrolling down, so down here we have equations that are not in standard form. So like number 17. Normally we would set this equal to 0, but since there's stuff over here other than just like a y or something like that, we have to do some rearranging. So that's why it says move, factor, and solve. So we're going to move the one that's out of place, which is this 21, and I move it by doing basically making it equal 0. So to make 21 equal 0, I'm going to subtract 21. And to maintain equality, I have to do it to both sides. So what I do on one side, I have to do to the other side. So on the right side, it cancels out. What's 21 minus 21? 0. And over here, is there a like term that I could combine this minus 21 with? All right, there's no other constants that I could combine it with. So that means I just tack it on at the end. Does that make sense? That's how you move things. Because you can do whatever you want to each side of the equation as long as you do the same thing to both sides. It'll still be equal. So by subtracting 21, I now have set it equal to 0, and everything's on the right side, or left side. And then I could factor that and then continue to solve it. So like over here, how do I get that 4x to equal 0? Good. You would subtract 4x to each side. So it cancels out on the right side because 4x minus 4x is 0. Over here, if I write it in standard form, it'd be x squared minus 4x minus 45. That way it's like more in standard form. Does that make sense? And then you could keep factoring and solving it. So like I'll factor this one over here with my diamond method. So 3 and 7 multiplied is negative 21. One of them has to be negative. Right, it has to be on the 3 to get me there. So then I have x minus 3 times x plus 7 equal to 0. Set each one equal to 0 and solve for x. Sorry, I'm going kind of fast because we're running out of time. But then our final answer is 3 and negative 7. All right, we'll do some examples of these tomorrow, so don't lose your notes. Also, don't lose your practice because we're going to work on it tomorrow too. All right, but any questions before you guys go?